Good morning, this is Kasturi Day. Today I'm going to discuss the Electricity and Magnetism chapter according to ICSE syllabus class 7. Today I'm going to start with the Earth's magnetic declination. What is magnetic declination? Earth's magnetic declination. We know that Earth has its own magnetic field. Therefore, when we freely suspend the magnetic needle, it will rest in the geographic north-south direction. Okay, that is, what is geographic north? That will be the magnetic needle's north, and the geographic south will be magnetic needle south. Now, Earth's magnetic south pole will be the geographic north, and Earth's magnetic north pole will be geographic south. Okay, now since we know that unlike poles attract each other and like poles repel each other, so north pole of the suspended magnetic needle will be equal to geographic north, because the north pole of the suspended magnet will get attracted by the south pole of the Earth's magnet. Okay, and the south pole of the suspended magnetic needle will be attracted by the Earth's magnetic north. Okay, and that will be geographic south. Okay, actually the north pole of the suspended magnet is not exactly along the geographic north. And now we will see that the north pole of the suspended magnet, when we suspend the magnetic needle, the pointer which indicates the geographic north, okay, that will be, actually that north pole is slightly deviated from the actual geographic north. That is magnetic declination. Okay, so that the angle of horizontal between the magnetic north and the geographic north, okay, the magnetic north, not Earth's magnetic, the magnetic north which has been suspended for direction. So magnetic north and geographic north, the two difference, there will be an inclination. So that is known as, or the true north and the magnetic north, that is known as magnetic declination. That angle is called magnetic declination, and that is denoted by theta. Okay. So if this is the suspended needle, this is say we know that this is north, this is south. Okay, so this north, and when we suspend the magnet, we will see that it will be inclined in slightly little bit away from the geographic north. So this declination, this angle is called theta, or what do you say, magnetic declination. Okay, so I draw at a bigger state. Okay, so this is north, this is south, and if this is the magnetic needle, this will show, this is the north, this is showing the magnetic needle. Okay, so this angle from the true north, the magnetic needle shows this north, so this will be the theta angle, or we can say that this is the magnetic declination. So it is different at different places on the Earth's surface, and also it is different with different time. Same place it can be, but different time this differs. Q is positive, theta is positive if the magnetic north is towards the east of the true north. If towards the east of true north, then this is known as, this is positive. If theta is towards the west, this way, if it is showing, then this is negative. Okay. Now we come to electric charges. All objects, we know, they are made up of tiny particles called atoms. Okay, now atoms, we have charged particles. We know that atoms have charged particles, protons, neutrons. I mean protons, neutrons and electrons, but neutrons are neutral in charge. Protons have a positive charge, electrons have negative charge. And we know that under normal conditions, these number of protons is equal to number of electrons. Okay, and this makes that positive charge is equal to negative charge, and that is they are neutral in charge. It becomes neutral. So, in this way, the atom exists in normal state, normal conditions. And when this charge stay on an object, when this charge stay on an object, this is static electricity. Then we said it is a static electricity. And when these charges are moving, then we call it electricity or electric current. Simply electricity or electric current. And the SI unit of charge is Coulomb. Okay, SI unit of charge is Coulomb. Okay. Now we come to electric current. What is electric current? Now, atoms of most metals, they contain very loosely bound negative charged electrons in their outermost orbit. We know they have electrons which are negatively charged. Okay, these electrons always move around the metal atom, in the atom, and if these electrons are by chance, they are knocked out. Okay, they can be knocked out very easily, and they are said to be free electrons. Okay, under ordinary conditions, these free electrons move randomly in all directions in a material. But when they are allowed to flow in a particular direction, they constitute electricity or electric current. Okay. So, therefore, an electric current is defined as the amount of charge flowing past a point in a unit time. They are flowing past a point, one point from around a point. They are moving. They are flowing. So, when they are moving past a point in unit time, that is known as electric current. If we say that charge is equal to theta coulomb, which flows through a point in unit time, say in time t seconds. We say that, let us say, consider that q coulomb of charge is flowing through a point in t seconds. Then current will be I, which will be flowing through that point in coulomb per second. 1 coulomb, theta by t. That is theta by t coulomb per second. Or you can say coulomb per second can be defined as ampere. So 1 ampere is equal to 1 coulomb by 1 second. Or SI unit, therefore SI unit is 1 ampere. Or rather ampere. SI unit of current is ampere. Okay. Excuse me. So if we take that q coulomb or theta coulomb is flowing through a point, q coulomb of charge is flowing through a point in time t seconds, then current I is equal to q by t. And that their unit will be coulomb per second. Okay. Now coulomb per second can be said as ampere. So 1 ampere is equal to 1 coulomb per second. 1 coulomb by 1 second. Okay. So SI unit of current electricity is ampere. And sources of electricity are electric cell or battery, the mains from which the main current is coming, the generator, or the solar cells. Okay. So I stop here. I'll start with electric cell in my next video. Please go through the videos. If you have any doubt, please do write in the comment box. You can also give suggestions how to improve my video, so that that can help you a lot, and you can understand it much better. And if you like the video, press the like button. If you are a new viewer to my channel or not subscribed yet, please do subscribe to get the notification of my next video. Thank you.